July 2022. The James Webb Space Telescope sends back its first images. Scientists around the world start downloading the data, running the analysis, checking the numbers, and within weeks, something is wrong. Galaxies that shouldn't exist, galaxies too massive, too structured, too ancient, galaxies that our entire model of the universe, built over a century of science, says are impossible. One astronomer described it as finding a skyscraper in the ruins of ancient Rome. Another said simply, "We're not supposed to be seeing this." Before we get to what Webb found, you need to understand what Webb is. Because if you think it's just a bigger, better Hubble, you're underestimating it. Hubble sees invisible light, the light human eyes can detect. Webb sees in infrared, and that difference changes everything. Here's why. When light travels across billions of light years of expanding space, it gets stretched, its wavelength gets longer, it shifts from visible light into infrared. This is called cosmological redshift. And it means that the oldest light in the universe, the light from the very first galaxies, has been stretched so far that Hubble simply cannot see it. Webb can. Webb is looking at light that left its source 13.4 billion years ago. The universe is 13.8 billion years old. Webb is seeing the universe when it was 400 million years old, an infant. And what did we expect to find in an infant universe? Chaos, gas, dust, small, irregular, clumpy proto-galaxies barely beginning to form. Structure takes time. Billions of years of merging, colliding, settling. You don't build a galaxy overnight. That's what the models said. That's what every simulation predicted. Webb was built to see the first light in the universe, the first stars, the first tentative beginnings of structure. What it found instead made cosmologists stop and check their calculations twice. In the first months of Webb data, February 2023, a team of astronomers published a paper. They had identified 6 galaxies in the early universe, 6 galaxies from a time when the universe was between 500 and 700 million years old. And they were massive, not just large for their age massive, Milky Way massive. One of them was potentially 10 times the mass of the Milky Way, at a time when the universe was less than 5% of its current age. To understand why this is impossible, think about it this way. A galaxy the size of the Milky Way contains somewhere between 100 and 400 billion stars. Each of those stars had to form, from gas, from collapse, from nuclear ignition. That process takes time. Hundreds of millions of years of gravitational assembly, star formation cycles, mergers. The standard model says you cannot build a structure this large in 500 million years. It's like finding a fully grown ancient oak tree that supposedly sprouted last Tuesday. But here's what stops me. These galaxies contain hundreds of billions of stars. Each star potentially with planets orbiting it. Each planet with billions of years of geological and chemical history. These galaxies were already ancient, already fully formed, before our sun was even a cloud of gas. Before Earth existed, before the solar system existed, before anything we know existed. Whatever happened in those galaxies happened without us, long before us. To understand why this matters, you need to understand what it's breaking. The Lambda-CDM model is the standard model of cosmology. Lambda for dark energy, CDM for cold, dark matter. It describes with extraordinary precision how the universe evolved from the Big Bang to what we observe today. It has survived decades of testing, produced Nobel Prizes, generated thousands of confirmed predictions. It is not a rough sketch. It is the most rigorously tested framework in the history of cosmology, and these galaxies violate it. The model predicts a maximum galaxy mass for any given age of the universe, a ceiling, a limit imposed by the physics of how matter accumulates under gravity. These galaxies exceed that ceiling by factors of 10 to 100. In physics, when an observation exceeds a theoretical maximum by a factor of 10, that's not an anomaly, that's a contradiction. Erica Nelson, one of the lead researchers at the University of Colorado, described the findings as bananas. Joel Leisure, co-author of the February 2023 paper, said that if the results hold up, and he believed they would, we need to fundamentally rethink our understanding of how the universe formed. These are not fringe scientists. These are not outsiders with an agenda. These are mainstream cosmologists at major research universities, publishing in peer-reviewed journals, saying, our model might be wrong. The standard model of cosmology is not a guess. It is the product of a century of observation, mathematics, and peer review. These galaxies don't bend it, they break it. And right now, nobody knows why. There are 3 serious scientific explanations on the table. None of them are comfortable. Explanation 1. Measurement error. Maybe Webb's distance measurements have systematic errors. Maybe the redshift calculations aren't as precise as we think. Maybe these galaxies are closer than they appear, and therefore younger and smaller. This is the comfortable answer. The "it's fine, the instruments are just new" answer. Most scientists consider it unlikely. The detections are too numerous, too consistent, confirmed by too many independent teams. But it cannot be completely ruled out. Explanation 2. New physics. Maybe the early universe had conditions we don't fully understand. Different dark matter behavior, different star formation rates, physical processes that operated differently in the first billion years than they do today. This is scientifically exciting. It means the universe has rules we haven't discovered yet. New physics waiting to be found. It also means that everything we know about the early universe, every simulation, every prediction, every model, is missing something fundamental. Explanation 3. The model is simply wrong. Lambda-CDM, despite its successes, may have gaps large enough to drive a galaxy through. Rebuilding cosmology from scratch is not something scientists take lightly. Decades of work, thousands of careers, an entire framework of human understanding. But it cannot be ruled out. None of the 3 explanations are comforting. The first means our instruments are less reliable than we thought. The second means the universe has secrets we can't yet access. And the third means that everything we thought we knew about how we got here might be wrong. Let's step back from the science for a moment and think about what this actually means. We built the most powerful telescope in human history. We spent 25 years and $10 billion building it. We pointed it at the beginning of time. And the first thing it told us is that we don't understand the beginning of time. But that's not the part that gets me those impossible galaxies. The ones that shouldn't exist existed for billions of years before our solar system formed. If galaxy formation can happen that fast, if massive structured galaxies were possible that early, then the conditions for life might have been possible that early too. Not necessarily, but chemistry, complexity, time, billions of years of time that we knew nothing about. We are not the universe's first attempt at complexity. We might not even be among the first million attempts. And here is the line that I can't stop thinking about. The universe is not 13.8 billion years old in a way that makes us early. The universe is 13.8 billion years old in a way that makes us very, very late. Whatever came before us, in those impossible early galaxies, in that first billion years we thought we understood, had a head start we can't even calculate. And we built a telescope to find evidence of our origins. And instead, found evidence that our origins are far stranger and far older than we ever imagined. Webb has been sending data back for over 2 years now. Every few months, a new paper, a new anomaly, a new thing that shouldn't exist, but does. The universe-breaker galaxies were the first signal that something is fundamentally wrong with what we thought we knew. They weren't the last. Webb recently detected something in the atmosphere of a planet 120 light-years away that has no business being there. Something that, on Earth, is only produced by living organisms. Scientists are cautious. They're checking the data, but they haven't been able to explain it away. That's the next video. If the universe being stranger than we imagined is your idea of a good time, subscribe. We're just getting started.